All right, this is the last example from section 9.2. It's a good test, free response type of question. So, make sure you know how to do this. A gaming website has made a claim that 20% of students aged 8 to 18 play video games at least once a day. You think this claim is false and that the true proportion is less than 20%. So you decide to test the following hypotheses. Null is 20%, alternate is less than 20. You're going to take a sample of 1,000 students and run a test at a significance level of 0.5. A web applet calculation cited the power of this test is 78% against the alternative of 17%. So what this alternative means is that's the true. Here's what it means. If the true proportion of people that play video games is 17%, then you have a 78% chance of rejecting the null properly. That's power. If you change this or change your sample size, it'll change everything else. Explain in simple language what power if 78% against the alternative means in this setting. Well, I guess I just answered that question. If the true proportion of kids that play video games is 17%, then we have a 78% chance of getting a sample that will cause us, or maybe allow is a better word, will cause us to reject the null and conclude the true proportion is less than 20%. You might say, well, of course you know it's less than 20%. The true value is 17%. Well, yeah, I know that. But the thing is when you are actually doing this test, you don't really know what the true value is. This is just saying if the true value is 17%, then you got a 78% chance of getting a sample that will allow you to reject the null and conclude that it's less than 20%. Keeping the significance level the same and the same alternative P, what would you do with your sample size to gain higher power? More power, increase sample size. What does this cost you? Time, money, resources. Kind of a stupid question. Keeping the sample size the same and the alternative P the same, what would you do to the significance level to gain power? Well, you would increase your alpha value. You want to increase power, increase alpha. Alpha is 0.5, increase alpha. What would this cost you? This will cost us an increase in the probability of a type 1 error. So yes, this will increase your power, and it will actually decrease the probability of a type 2 error. But the cost is an increase in the probability of a type 1 error. And that's not good, right? Keeping the sample size and significance level the same, what could you do to the alternative P to gain higher power? So we want to increase our effect size. The true value, or the hypothesized value was 20%, and the true value was 17%. That is a 3% effect size. If we want to increase our power, we need to increase our effect size. So maybe we would have to decrease the true value. Decrease P, make it lower than 17%. Why don't we have control over the alternative P? I don't know, you just don't, right? I'm just kidding. Don't answer an AP test like that. Question test. Don't answer an AP test question like that. But we don't have any control over what the alternative P is. You know, there's a true value out there. We don't know what it is, and we certainly don't have control over what it is. We kind of just say, well, if it's this, then my power is this. If it's this, then my power is what? You know, that's all we can do. So you don't have any control over it. All right, that concludes section 9.2. 9.3 is next.